We have a MacBook Pro. This is a 15 inches. It says no power. It's an A1990. That's the model number. It says A1990. That's the model number. So, as usual, for no power devices, it's not advisable to. You can try to power it on using the power button. It's no problem doing so. However, it's not advised to connect power to it until you can establish the state of the board. So first thing we want to do is we want to take out the back plate. That way we can establish what is it that we're looking at. Okay, screws are out. If this is the first time you're doing this, you want to be sure that you are aware of your screws configurations. Now, usually what I do is, first thing when you take out the back of your device, the first thing you want to do and the last thing to do is to disconnect the battery. So with this, there are the dual battery management system built for this device. So you have the BMU cable, which is the data cable, and then you have the main battery power line. So on top of it, which is this cable here, it basically it connects from the battery board up until the main logic board, uh, and then you have the main cable that runs from the board up onto the battery board. The main power line is going to be this, so I'm just going to disconnect that for you guys to see. So that is the data cable. So in an ideal situation with that cable disconnected, you have effectively stopped the flow of power from your battery up onto to your board. Now with the A1990s, usually what I do is the first thing I do is when I disconnect my cable, I want to look at the area of U9081 because so I want to look at especially this section here to see if there is any type of a bounty mark around here, or if my cap this because this cap here, this section here is ground, while this section is the main power line, which is a PPBUS. Now usually if you have a failed C9081 on the other side, it would sometimes affect, you will create a bond mark here, which also create a bond mark here, and that will create a short on your PPBUS. So as the A1990s, they are very susceptible to such damages. I'm just going to show you guys. So say this is okay, this is an A1990 board. C9080, this is C9080. C9081. C9081, it's very susceptible to failure, and that's a huge reason for that. It's because of the placement of that particular cap. So a huge reason for that is the placement of that particular cap. Um, so, welcome. He's busy. Okay, he will come. Okay, welcome. So, so one of the reason why the C9081 failed is because of the location of the chip itself on the board. So it's very common for it to fail. And I would actually advise that if you are working on the A1990s, even if you don't have a problem with C9081, the fact that you are able to get access to the board, to take the board out, remove the capacitor from the board. That way you are able to initiate a preventive measure, because it's a component that is definitely going to fail, because there will be a buildup of moisture, and then you have dust in that section, and then because of you have a high voltage line, PPBUS 12.6, it's going to collect dust, and then it's going to become it's going to get corroded, and then the cap is going to be shorted. That cap shorts in two forms. Sometimes the damage is contained in itself, where you have to remove the cap from the line and you're good to go. But other times the cap doesn't just damage itself. What it does, it damages itself, and then it burns a hole. So that's the main line. I'll just show you. It basically burns through the board, and then it damages. You have a hole here, which then damages U9080. And then what U9080 would effectively do is U9080 will send 12.6 volt on your suppose 2.5 volt line. So if you're working on the A1990s, even if you don't have an issue with C9081, please remove it, because that will save the client so much. Okay, so that's it. Now we have disconnected the battery cable, and as far as we are concerned, this looks very much an original battery. So with the cable disconnected, we are certain that there's no more power from the battery to the board. Now, we did look at that section of U9080, and we do not see any sign of burnt mark there, which is good. The next thing we want to do is we want to see if we have a short on our PPBUS, and then that we can confirm using any of these fuses that are sitting on the PPBUS line. So we are going to use the loud guy. We are setting our multimeter to continuity mode. So I'm just going to touch my probe to be sure. Okay, so that's my continuity mode. So what I want to do is I want to place my black probe on ground. I can use any of the cowlings for my ground, or I can use a screw hole for my ground. Just to confirm that also on ground, I do that. Okay, so what I want to do is I want to check my PP bus line. Okay, and then that is a short. And then, like I said, say we have a short on our PPBUS, and U9080, it's very, very common to fail. So what we quickly want to do is, sorry, what am I saying? It's C9081, so not U9080. When C9081 fails, that's when it eventually affects U98. U98. So what you want to quickly do is, because you have a short on our PPBUS, most likely it's an issue with C9081, which is the cap that we just spoke about now. So let's quickly take the board out and see if that is the case. We hope that is the case. So I'm going to start with the T5 screws. All of those that I just took out now, they are going to be of the same size, except this. This is going to be slightly longer. With the 16 inches, that screw, you have two of it, one on the right and then one on the left. So if you place them, if you check them, you see the difference. I don't know if you can pick that up. Hmm? It's slightly longer. Okay, that is T5, and also the battery. I'm going to be using a T5 for the battery screw. Another difference you want to see, so you see with the 13 inches and 15 inches, the battery screw, it's short, while the 16 inches battery screw is long. Let me see if I can get a 16 inches battery screw here. So this is a 16 inches battery screw, and that is a 13 inches. So this is a 13 inches or 15 inches battery screw, and then this is a 16 inches battery screw. This screw is unique to a 16 inches only, but this you can use on the 13 inches and then on the 13 inches, 14 inches, and also even, and by the way, when I say unique to 16 inches, it is unique to 16 inches A2141 only, because the 16 inches Intel, it's now the 16 inches Intel is now on the 30 with they use this screw size and not this screw size. So this is only what you find on the A2141. Okay. Okay. So we are going to take the board out of the shell. We already have all of the screws out. So I would say if you are going to use a tool, it's best to use your hand wherever you can. If you are going to use your tool, make sure you do not hand complete control to your tool. And by the way, take note of the touch ID cable underneath your audio jack. Okay, so there's no harm using a tool, but then if you have to use a tool, especially a tweezer, make sure you do not hand complete control to it in terms of not being aware of what the tool itself is doing. So you want to make sure that you are aware of it. You don't want to rip out anything. And again, especially the the touch ID cable, because that's just gonna throw you off. Now there are no particular ways you take this out. You can either take it out from the right or from the left. But the one thing to take note of is while you're taking the board out, you want to make sure that you are slow, and you want to make sure that you're looking out for any form of resistance, whatever cable that is preventing. For example, the duct tape that we have to release a little bit on both fans. Whatever cable that is preventing the device from the board from getting out of the shell, you want to take it out, please. And again, especially the Touch ID cable. Now you see the dust accumulated on your right side as well as on the left side. That is a key reason why your C9080 fails. So you have your dust on your left as well as on your right. So that is a key reason, and especially given the position of C9081. So C9081, you see C9081, because of the location of C9081, you see on your left hand side you have the same accumulation of dust, but you don't have capacitors there. But on your right hand side you have the same accumulation of dust, and that is where you have your C9081. You see where C9081 is positioned. You see the dust, and you see C9081 is positioned exactly at that point. You have the same dust accumulation, but not so much, and there you have no components that will collect that dust. Now on the other side, you have C9081. It's sitting on a 12.6 volt line, and it you have a build up of dust, and then you have a moisture which then results in corrosion. And then whenever it happens, what happens is you see that the capacitor itself fails. Sometimes you are lucky that it fails within itself, and then the failure is then extended onto U9080, and which would then mean that your NANDs will be safe. Sometimes the failure is extended, so which is the capacitor fails, and it damages a U9080, and then by extension U9080 also damages your NAND chip. So this cap, it's actually a very common failed part on the A1990, very common. So if you're working on the A1990s, even if you're actually not having a situation that requires you to remove C9081, the cap, I will advise to remove it. And when you remove it, do not replace it. So you see how that build up. And then another thing you want to do is that when you're doing a repair like this one, make sure you clean out the board as well as the dust that's been accumulated uh, 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 um, in the casing. And also for this type of repair, you do not really need a soldering iron, nor do you need a hot air gun. So you just need something to basically move the cap out of the way. Okay, so you want to make sure that you clean off the shell, and while you're doing so, you want to be aware of the cables inside, especially the Touch ID cable. You don't want to break it. So you're just going to quickly dust out the shell. Okay, now we want to put that on the side. Okay, so now back to the board. So what you wanna do now, we just wanna confirm again that indeed we have a short on the board. So our black probe on ground, and then our red probe, and there you have it, 005. That is a short, that's a dead short. So we have a short on the line, so we are going to remove C9081. And like I said, removing of C9081 from the PPBUS line, you do not need to use sodium ion, nor do you need to use a heat gun. So you can just use a tweezer, for example, so to take it out. And alhamdulillah, that C9081 damaged, and it did not affect U9080, which is a very good thing. So we're just going to use a tweezer, the bottom of a tweezer, to remove C9081 from the rail without having to yeah, that's it. It's just as easy as that. So in a repair like this one, you actually do not need anything more. That's it. And that fixes the problem. So let's check again now. Black probe on ground, and another red probe. That's it. Now you have a high resistance to ground, unlike what you used to have. So that's it. That's it. That's the fix. It's just as simple as that. So, but the beauty of this one is that, Alhamdulillah, that the failure was contained within itself. There are other times that the client will not be so lucky that the failure would extend to U9080, and when that happens, the U9080 will send a 12.6 volt to your NAT. And by the way, you see, I'm not going to put it back, and then the reason being that this is the C9081 follows a wear and tear cycle, which is the more. So I'm just going to show you on the schematic real quick. So U9081 C9081, it's one of the four caps on on a PPDC on a PPBUS on the PPBUS line to U9080. So there are four caps on the same line over U90 as C9081. So without C9081, you still have C9073, C9074, as well as C9080. So with C9081 not being present, it doesn't really matter. Now, 90, C9080, 74, and 73 would do perfectly fine. Given the position of C9081, it's not ideal to actually leave it on the board. And then I would even say that if you're doing a repair that is even different, that has nothing to do with C9081, provided you have C9081 on the board, it is best to remove it, because yes, it's yet to fail at the time that you're doing the repair, but I tell you, over time it is going to fail. So the best thing you want to do for the client as a preventive measure is to make sure that you remove C98, C9081 from the board. Okay, so that said, we see we no longer have a shot on the board. That's that is all we need to do the actual repair. So what we are now going to do is we are going to uh, so there are sometimes you have a repair like this one, and then after you put the board back, you only get trackpad feedback but nothing. So what you want to do is you want to use Apple Configurator 2 to see if the device is ever stuck on recovery. So let us put the board in the shell, because if it's stuck in recovery, the device will not start. You will only get trackpad feedback, but that will be about it. The device will not start. So let's quickly put the board in the shell and see if we have a working board. I am hopeful that the board should be working now, especially given that the device itself is not liquid damage. There is nothing that suggests that there is a secondary damage to the failure of a C9081. So, and we no longer have a short, which we had initially. So I am hoping that that is the only repair required. So yeah, so we are just quickly going to put the board in the shop. Um, so we have checked that we no longer have a short on our PPBus, so we are quickly going to test the board to see that the board is now working. So I'm going to, ideally I would connect only the cable that we need for the testing, but because I'm a bit confident that our problem is going to be solved. I'm just going to go ahead and connect all of the cables. Okay. Depending on the charger that you have, it is better to have an 87 watts of charger. So you may want to connect your battery. But if you have the right amount of the right charger, then you don't necessarily have to connect to your battery for the device to start. Okay, so that is that. We are quickly going to test to see if we now have a working device. And just connected. We're going to see if we get a fine spin. That's a fine spin. Hopefully, we should have Apple logo now. And that's your Apple logo. Okay, so that is something that's going to be taken care of by the company. Okay, so just to recap, this was an issue. So I'm just obviously do I'll start putting the device together because of time. So this was an issue with C9081, and then like I will stress that if you are working on these devices, you want to look out for C9081, and even if you're not dealing with an issue that relates to C9081, it is better to have it off the board because that way the client will not risk having a dead machine because of C9081, and the device will work 100% without C9081. So this is a common issue with the A1990. But then again, if you are working on these devices, you do not have a blank approach to all. Before you apply any type of assessment, any type of pre-assessed pre-assessed result, you want to be sure that your board is actually the failure pattern of your board is actually that you have showed on your PPBUS lines. Yes, it is a common issue with the A1990, but that doesn't mean that it is the only issue with the A1990. Even though your device might not power on, there are many times where the issue itself is not C9081. So please, when you are working on these devices, just be sure that you apply the right approach, which is something that you will only get from proper assessment. So you have to first assess your device, then you can determine what the issue is, and then from there you know what to do to address the issue. Quickly putting back the screws. And please, it's also important that you know what screw goes where. It's very important. Oftentimes, your fellow techies will judge you according to your screw placement. So be sure to know where your screws are placed. And if it's your first time doing this, whatever approach works for you, the most important thing is to do to make sure you do a proper job. So whatever approach works for you in form of identification, you follow it. The most important thing is you do the right job. Yes, yes. And also, when you after your screws are in place, you want to kind of look around just to be sure that all screws. I think there was one of it that yeah, to make sure that all screws are in place. Even though you might sometimes be in a hurry, but just make sure the job you do a proper job, even though you are in a hurry, so you don't miss out anything. Okay, make sure the back is snapped into place, and the screws, they are not all of the same sizes. You have two, which will be at the back here. They will be you choose two here will sit at the back, while the other four, same size, will sit here. Okay, so still that screw. We are just going to confirm again that the device is fully functional. We have trackpad feedback. Waiting for the device to start. And that's your Apple logo. And then that's it. Thank you guys. I will see you guys in the next one.